Hello everyone, this is part 2 of project 1, where we simulate a shock in our CD nozzle. So you first start out by using the same geometry. I went over this in the last video, and you just need to make sure to save this as a .step file, and then you go into Workbench. You right here, you place geometry, you put it in, and then let's go to our mesh. Alright, let's see, our mesh here looks pretty decent. Once again, I used 5 meters element size and quadrilateral dominant method. And don't forget, make your name sections, inlet, your walls, and your outlet. That's all you really have to do for meshing. You can obviously spend a lot of time refining it, makes your results a bit better, but that is completely up to you. Now let's go to the setup. Alright. Wait for this to load a bit. It's basically part 2. You get all the same plots, but you try to get a shock in your nozzle. So we do that by increasing back pressure. So once again, make sure it's density based. Go to your models, turn on energy. Go to your model type inviscid. Fluid, go to air. Make sure it's ideal gas. Good there. Go to your boundary conditions. Create a pressure inlet again. And let's see. Let's go over our inlet pressures. So kept the same for inlet, 186 pascals for total pressure and 400 Kelvin. But here on the outlet, here's where you gotta change stuff. So I did 400,000 pascals, 480 to 5, and across a shock, your temperature stays the same, so it still should be 400. Make sure this is static pressure, very important. Go to our conditions, operating conditions, make sure everything's 0. Everything's 0. Alright, now for this part, under controls, I had to fidget with my crot number a little bit. That's basically how your residuals are displayed. The default is 5. I went to 2 for this. And for a shockwave, the crot number is very important because sometimes it can be hard to initialize. And let's run it. This will take a little bit. So we're basically doing the same thing, just for the shockwave. And you'll see on the contours and the plots how a shock affects those. It's quite interesting. Anyways, let's look at our residuals. Excuse me. Residuals can be a bit high for this. It's important to look at where the shock happens. there we go. Our calculation's done. Let's go to graphics. Easiest way to tell if you have a shock, just go to Mach number. Let's get this fitted. And you can easily see the shock. It was about 2.63 Mach number. Goes across shock. Obviously going to go subsonic and get even more subsonic across. So let's do our plots here. Pressure, temperature, density. Let's go pressure contour. So you see after the shock what happens to pressure. And let's go to temperature. Aftershock increases, temperature, pressure increase. Will be the same for density as well. And let's go to velocity. Velocity decreases. This coincides with what we know. Let's go to properties. Speed of sound increases. And Mach number will obviously decrease. Okay, and let's go to our plots. Now make sure you create a center line. You can do that by do surface, line rake, put in your coordinates. I already have one done, but let's go to pressure graph, and you'll see what the shock does to our graphs. Look, you can see it's going down. Shock happens, immediate jump because of that shock. And then let's go to temperature. Should be around the same. Yeah, even bigger jump for temperature. Density looks a lot like pressure graph. And let's go to velocity. X velocity is really what we need to focus on. Boom, it's increasing, comes way down because of that shock. And let's see Mach number here. Yep, same as velocity. And then let's see speed of sound. Decrease and then sharp increase. So, hope you guys enjoyed. This is what happens if we put a shock in the CD nozzle and how it differs from part 1 of this project. So, hope you enjoy.